So today we're going to talk about class templates in C++. If you have no idea what templates are, then I do encourage you to go back and watch the episode called Function Templates in C++. But today we're going to talk about class templates, and we're going to do something exciting. We're going to basically write our own vector class, something similar to the vector class that we have at standard template library. Of course, it's going to be sort of a very, very much simplified version of that vector class. But let's jump into our main.cpp. Don't get intimidated by the content which I added here, because these are just for testing our vector class, whether it works or not. But what you see here is basically I have something in quotation mark, a header file. This probably means that something that we want to implement ourselves, and that is the case. This is vector.h, sort of the interface for that template class. So I'm going to open my vector.cpp. That's the representation or the implementation. Currently it's empty. We're going to fit it up together. So let's open up our vector.h, because we need to know that what things we need to implement. So first thing to notice is that visually the vector class doesn't actually differ from any regular class. The only difference we see here visually, at least this template type name on top. This means that this class is a template class, and it basically relies on one template argument, which is called type. Another thing to notice is that usually you see out of habit we have interfaces and then we have implementations, but in this case sort of this vector.cpp is not actually a separate translation unit, because you need to add this inside at the end of your basically templated class. And that is because once the compiler wants to instantiate from this vector class, then it needs to know everything, every implementation of the methods and constructors and destructors about this template class. So this is sort of a hack, let's say, that we separated to a .cpp file and a .h file, but this is not really a separate translation unit. This is just acts like a header file because you need to add it here. Okay, let's jump to here and start implementing everything. We're going to start with the constructor. So you're going to see a lot of times that we need to repeat ourselves by saying template type name and stuff like that. This is a little bit boring, but we're going to do it. So we're going to say template, and then we're going to say type name type. And of course, this thing is going to happen a trillion times. Then I'm going to put this like a billion times. I don't know how many times I'm going to need it, but anyways. So I'm going to say vector type, and then this is my constructor. So I have elements here which are sort of pointers. So I want to start with a null pointer for them. I'm going to initialize my vec size, that's the size of my vector, to be 0 in the beginning. And then I'm going to initialize vec capacity to be also 0. That's the capacity of my vector. So that is my constructor, basically. Now we're going to go to the next one in the list. That's the destructor. So we're going to say, vector of type. And then that is my vector destructor. And all we need to do is to delete basically our elements, right? So of course, we also need this also a billion times. So I'm gonna paste to every line. I don't know how many times I need it. The next thing on the line is actually the size sort of function, which returns the size of the vector. So let's do that. It returns a size t. The method is called size, and it should be marked as const. And it simply returns what? Vec.size. Not dot, but vec size. The next one on the line is the pushback method that we want to add something to the vector. So of course it's a void. And we're going to have a pushback method here, and it gets a type reference element, Okay, if you want to push back, the first thing to notice is that you need to have some space in your vector. So I'm going to check whether my vec size is equal to my vec capacity. If that's the case, then I need to increase my capacity, and that is the method that we have right here, double capacity. You can follow any strategy you want, but here we're gonna basically each time that we fill up our vector, we're gonna double the capacity for that vector. So I'm gonna say double capacity. But if actually we do have a space to add elements, the only thing you need to do is to say elements of vec size. It should be equal to element. And since we added one element, the size need to increase. So I do a vec size plus plus. The next on the line is remove add. So let's add this one. It's a void. It returns void. Let's remove add. And it gets a std size t index. And what it does is basically, okay, if you want to remove something, again, you need to check whether the index is something which is valid. So I'm going to say if my index is greater than or equal to vec size, then I need some error handling. I can use exceptions here. I can throw an exception. I can say throw std out of range with a message that says index out of range. So that's what I'm going to do in this case. But if it's a valid index, all I'm trying to do is basically have a for loop size t I, which is from index, and I smaller than vec size -1, and then I plus plus. Okay, what I'm trying to do is to shift everything to the left. So I'm going to say elements I, elements I plus 1. So after I did that, since one element is removed, I need to say vec size minus because one element is gone. So the next thing we need to do is the print operation. Let's implement this one. It's of course a void, and it also is marked as const because it's not changing the status of the class, the vector class. But I need to check whether the vector is empty or not, because if the vector is empty, then there's nothing to be printed. So I say if vec size equals to 0, then what I can do is to print something meaningful. I can say empty vector. So, and then I say std line, and then I can return basically. But if not, if I have valid sort of elements inside my vector, then I need my for loop, which I can basically copy and paste it from here. It's essentially the same, but we're not going to start from index. We're going to start from 0. But before that, I need to maybe print something meaningful, like v and then this thing. And then I can add my elements. Like I can say std cout elements of I. And between each element, I can put also a comma. I'm not going to put the end line. I'm going to say for the last one, elements of vec size -1. That's the last element in my vector. And I'm going to close the bracket that I opened. And I'm going to say std end line. So there we go. Now we have our operator, which gives the bracket operator for the random access. So let's go and apply that. That's a reference, and this thing is operator. And it gets a std size t index again. So the same check also goes here, whether we have a valid index or not. So I'm going to copy and paste literally everything there to here. But if it's a valid basically range, or if it's a valid index, then I need to basically return that element. So elements at index should be returned. So the only thing which is remained, I think, should be double capacity. So let's do it. It's a void and it's double capacity. For the implementation of this one, then I need to increase my capacity, of course. So vec capacity should be, whoops, times 2. And then I need to basically allocate some new stuff on the heap. So I'm going to say type star. I can call it as new elements. It's going to be a new type with the updated capacity, which is now twice as large as before. Now I'm going to basically copy everything. So I need my for loop right here from 0, but not to vec size -1 because I want all my elements to be copied. So I'm going to say new elements at I should be equal to elements at I. So after I copied every element that I had, then I can get rid of the old allocated memory. So I'm going to delete my elements. And then I'm going to assign this new elements to my elements. The only problem is in the beginning when we have the capacity. So when in the constructor we said the capacity and the size, both of them should be 0. So I'm going to check because 0 times 2 is going to be 0. That's going to be a little bit dumb, right? So I'm going to say if vec capacity equals to 0, then simply do a vec capacity plus plus. The rest of this stuff I think is extra. So I think pretty much we have implemented everything, right? So yeah, we have the constructor, we have the destructor, we have size, pushback, remove add, and print. And we have our operator as well. Also, we have the double capacity. So I think this should be good out of the box. So if I compile this, oh, that's good. We didn't have any errors. That's actually very good. So we can try this to see whether it works. So right now you see that this is the test I was talking about. So the first one is a vector of doubles. So I have 1.2, 2.54, and 3.79 inside my vector. Before I remove the index 0, which is the first element, which is 1.2, the size is basically 3, which is correct. I have 3 elements in my vector. Then I remove the element at index 0, or let's say the first element I have. The size is going to decrease to 2. And then the elements which are remained are 254 and 379. So this works out of the box. And then to basically show you that it's generic, it works for doubles, it also works for integers. So we have a vector of 4, 5, and 6. The size is, again, before removal, it's 3. And then we remove the first one out of this array as well, out of this vector as well. Then we're going to left off with 5 and 6. Then this empty vector you see here is because that I have removed 2 times more to basically empty my vector and to test whether my print basically works properly when I have no elements inside my vector. The last thing to basically test is that exception part. So here I have 3 elements in my vector, but the index starts from 0 in C++. So the valid indices are 0, 1, and 2, but I'm trying to access and print the basically index number 3, which is invalid and it's out of range access. So let's compile this thing and try to run it. And you see that it throws this sort of on-caught exception and it says index out of range. So there we go. Now in this video, you learn to write your own custom vector class with the notion of class templates. I hope you learned something from this video and hope to see you in the next one.